In this problem, we're going to answer a word problem. So, this is from the homework, and it says, the line graph shows, and we'll get to the line graph, the cost of inflation in some country. What cost $10,000 in 1975 would cost the amount shown by the graph in subsequent years? So we're thinking of years after 1975, and we're taking $10,000 and we're going to figure out what it would cost to purchase that item now. The wording gets a little strenuous. We're also going to be looking at two mathematical models for the data shown in the graph. And in each formula and in everything we're looking at, C is going to represent this cost. And C is expressed in the cost X number of years after 1980. And I've got 1980 circled because that's in contrast to the $10,000 in 1975. So let's take a look at the first question with the graph. And in this question, we're looking at using the graph to estimate the cost in 2000. So how much $2,000 would it take to get something from 1975? We take 2000 and we subtract from 2000 1980, and that's going to give us 20. So we're 20 years after 1980. But in this chart right here, the cost of inflation chart, I've got 2000 marked out because we're talking in terms of, let's make this a straight line. We're going to go up here to above 2000, see where that intersects the graph, and then we're going to go out and see what that cost is. And to me, that looks like it's $31,000. So $31,000 in 2000. That's our cost. $31,000 in 2000. Okay. Now, let's take a look at these mathematical models, these equations that we're looking at. So we'll get rid of this. And again, we're talking 20 years after 1980, and we're going to need that. Pardon me there. I'm going to get rid of this stray mark. And we'll pull up the first model. So for model 1, the cost is equal to 868 times the number of years past 2000. That's X right there. Plus 15,529. So our cost is going to be 868 times, 20. And we're going to add to that 15,529. Now we could calculate this all out, or we could just grab our calculator. I'm going to grab my calculator, and I'm going to take and input, let's see here, 868 times 20 plus 15529. Yep, that looks correct. Enter. I get $32,889. Okay, so I'm going to write that down. My cost is $32,889. Now, on our graph, we got $31,000. So that's going to be a difference of, what is it? 9,881. $1,889. I could subtract 31,000 from my answer to get that too. Okay, and that's with the first model. Now we're going to do this all over again with the second model. So let's pull up the second model here. Alright, we're going to use Model 2. Model 2 is a little bit more complicated. Let's move this calculator out of the way here. There we go. Model 2 is a little bit more complicated. It says that it's a negative 2 times x squared plus 930x plus 14,257. I don't know about you, but I'm having trouble here punching in 20 all the time. So I'm going to take 20. I'm going to store it as x. I'm going to store it as that variable there. And I think you can see the keys that I pressed. Great. 20. So now if I hit x, I'm going to get 20. If I do 2x, you know what I'll get? 40. If I take x squared, oops, not to the minus 1, x squared, I get 400. Great. So let's take a negative 2 times x squared plus 930x plus 14257. These very arbitrary looking numbers. And we get the cost to be $32,057. Okay, so our cost, negative 2 times 20 squared plus 930 times 20 plus 14257 is $32,057. And again, we want to figure out how much more than the data shown on the graph that is. So we subtract 31,000 from it. And we can again do that from the calculator, minus 31000. We get 1,057. So $1,057. That's our answer there. Oops, not C, pardon me. All right. Thank you. I'll see you next problem.